Hello, good afternoon, everyone. My name is Jin Ye. I'm the senior researcher on Kaspersky Grid team, and I have been working at Kaspersky for over 7 years. And my main job for the past 12 years has been malware research and analysis. And today I want to share the dropping elephant attack we have seen in the past year. The past years, global geopolitical conflict have intensified, and accordingly, more and more APT attack continue to emerge. And one of the hottest areas is India and its surrounding countries. For years, we have been tracking the activities of relevant APTs groups in this region, including Bitter, Dropping Elephant, Origami Elephant, and Confucius, and Sidewinder. So among them, Dropping Elephant group has been particularly active in recent years. So we discovered a lot of campaigns and captured thousands of samples. Based on this large-scale sample set, we could extract a large amount of metadata, which allowed us to perform some statistical analysis and discover some interesting things, such as the working patterns of the operators. So my presentation consists of 3 parts. The first part is some interesting statistical conclusion, and secondly, we will see the initial infection process commonly used by dropping elephant, and some multi-stage samples we have seen in the attack campaigns. The last one is something about the C2 infrastructure. From the second half of 2021, we have seen captured many samples from dropping elephant, and we have seen the dropping elephant continue to upgrade its weapons. Unlike most APT groups, dropping elephant developed many POC samples to test how to bypass antivirus detection. Sometimes the compile time between different samples is only a few minutes, so we assume that the main part of the sample set is POC, in which case the compile time and the detection time is not close to the time of attack, but rather the time of development. So to avoid being fooled by the fake compile time, we checked some samples compile time, the detection time. And in most cases, the two were very close. So therefore, we believe that the compile time is credible. Through these POC samples, we discovered some interesting timeline patterns. We gathered 1.5 years of attack events and then count the number of attack by day and month. It was clear that there was a peak in October of 2021. We also saw some public report that dropping elephant launched intensive attack at that time. And we then analyzed the detection time within 1 day, within 24 hours. Since the dropping elephant has been attributed multiple times by different vendors, we know that the victim and the attacker are unlikely to be in the GMT 0 time zone. So this statistic may not be easy to interpretable. It doesn't make sense. So let's crack the time zone and take another look. It's known that the attacker may have come from the Indian subcontinent, so we shift the time zone to GMT +5. And now we look at the distribution of activities. We can find a reasonable explanation. The developer start work at 9 a.m. and start lunch at 1 p.m. and then stop work at around 6:30 p.m. The activity perfectly matches the working hours of people in the GMT +5 time zone. So that strongly supports our guess that the compile time of the POC samples can reflect the working hours of the developer. As you can see, they have nice balls because they don't appear to work overtime. Then we move to part 2. Let's dive into the samples and reveal more details through reverse engineering. We start with 2 most representative initial infections and drill down to analyze the variation of dropping elephant samples. We have seen various of multi-stage attack execution flow, and the payload can be flexibly combined. From the general execution flow chart, we see that there are 3 different initial infection vectors. The first is the RTF document that explored Office vulnerability. And the second is IRSF extracting program. And the third one is one-time customer loaders. So accordingly, we can see that there are 3 different types of multi-stage execution flow. Each type has different structure and use to load different payloads. Let's look at type 1 first. Starting from the exploit document, there are 3 options to load different payloads. As the first stage, these payloads include Pub Fantasy and Jekyll High, and some other known tool sites. This is stage 1. It will then download plugin to achieve different goals. The second time is relatively rare and use IR archive to release VB script and bat script and Pub Fantasy. The dropper will execute VB script first. The VB script then run the bat script will run the Pub Fantasy. We have seen many POC samples use this execution flow, but we have only seen one example that was actually used to attack users. Among them, type 3 is the most complex execution flow, and the customized dropper is used to release the CS crypta and the crypta. These both are loaders. CS crypta will load the Quasar, another RIT as a final payload, and the crypta will load the backdoor such as Buzok, Just Chill, and Turbo App, and Jekyll High. Of course, it will use Metasploit shellcode to load other framework. Let's see some examples. From 2021, Origami Elephant began to launch phishing attack using the theme of COVID-19 epidemic. This sample was obtained from the public channel. The information of the last saved user in this document tells us that the target of attack is likely to be a company in Pakistan. And Origami Elephant delivers malicious RTF documents through spear phishing emails and start to exploit the CVE 2017/11AA2 to attack the office, then triggering the shellcode. Then the shellcode will be loading the backdoor. The backdoor is Jekyll High. We notice this backdoor uses a legitimate certificate we have exposed before. So according to our statistic, most of attack from Origami Elephant used the past year have exploited CVE 2017/11A2 vulnerability. And apparently, Origami Elephant has keep update exploit kit. Taking type 3 as an example, we see that attacker use a famous avatar as the icon of the exe file to lure the target to click on the initial program. Then drop an open picture to confuse the target. The dropper then will extract the data from itself and write it to this file. This is path appdata Microsoft /Windows update and /Microsoft.dat. Then if we read the data from Microsoft.dat again and finally write it to the raster.exe file, this exe file is script loader. In generally, dropping elephant attack in the initial stage is more flexible. Sometimes the shellcode will directly release the Jekyll High, the backdoor, and sometimes it will write a one-time release program and then use multi-level loading to deliver final IT. The .exe malicious program itself is a crypto loader, and its main function is to detect AV product and choose an evasion scheme. Then decrypt the resource file with ID 10 and load the final malicious program through the process hollowing to avoid being detected. This main code are still using in the most recent captured version. So the malware loaded in the example is a brand new RAT developed in Delphi, which we name it Turbo App. We will talk about it later. Next, it will escalate privilege to ensure that ability to read and write across processes. Then hijack the RAT of the system module like NTDLL to bypass some AV hook mechanism. And finally, copy itself to another place. It will create a shortcut in startup directory through the COM interface to complete the persistence action. It was mentioning that some new persistent technical have been added in the recent attack. Depending on the AV installed in this host, it will choose a solution for auto-running. So when it encounters some certain AV product, it will release a very small PE file here to time pass, and then start it. This independent process will help the parent program to achieve persistence. So we call this independent PE file mini auto-reg. Before starting the persistent operation, the crypto loader will copy itself to another place. In this case, we will choose to use some tricks. In other cases, if you choose to use some tricks to directly implement self-installing. For example, edit or insert some normal network behavior into a function that operates registry. This may be to fight against some behavior detection system. Mini auto-reg, this small gadget has only one goal, is to help a crypto loader to achieve persistence. And the code logic is simple and straightforward. And we have seen two variants based on how self-starting is implemented. This is one of them. So the schedule task is created with COM interface. So which point to the path, program data, some random letters, and seeing host.exe, as shown in this picture. This is crypto loader's path. Turbo App. Turbo App is a new backdoor family developed in Delphi, and at first we thought it was a new variant of Buzuk. But after code comparison, we found this is a brand new family. In terms of code function, it's more like a Delphi version of Jekyll Hyde, but it has similarities with a structure of Buzuk's communication protocol. First, a sample will create mutex to keep a single instance, and then perform a series of operations to obtain the host information. The final online data is as shown in this figure. It included UUID, the computer name and username, operation system language, and operation version, IP address, something like that. And the encrypted online data is here. The network data encryption method is RC4 plus base 64. With hard-code RC4 password, which is the same as pub fantasy encryption algorithm. This table shows possible C2 command and functions. It's supposed to get drives information and upload files, download files, and execution new process, and execute command via CMD. In our previous research, we have analyzed a kind of variety. We name it pop fantasy. Dropping Elephant upgraded these tools in the followed-up attack. The sample had changed greatly from the original one, and there were some new things used to fight against AV detections. For example, it checks the special file existence in the time folder to ensure that the process running as a single instance and the system UUID is obtained from the COM interface instead of the old version by the command line. Then it provides the service information and other service information and other process information through PowerShell and the task list. At the same time, it will check software installed in the system through registries, so also recorded in the CME file. Finally, it encrypts all the above information with RC4. The key is a very long string as shown here, ABC something. Then it saves it to this file in time folder, RTY-GG-FDG. To compare with the old one, the new version of pop fantasy has completely abandoned the process of passing C2 through that drop. And instead, it uses hardcode C2 indirectly. So the most obvious change is use of new communication encryption algorithm. As I said, use RC4 plus base 64 and abandoning the simple XOR algorithm. These files used to save the files used to save the sensitive information also use the same encryption algorithm. As mentioned earlier, this encryption method is the same as the Turbo app use. It looks like Dropping Elephant is trying to use different programming language to implement a similar program logic. Taking an online packet as an example, you can see that the key data item has been encrypted and encoded, but the data in the UUID and FAT, and these two items was only encrypted with RC4 without the base 64 encoded. So if the encrypted data contains byte 0, the data will be truncated when string formatting. This is an obvious bug. On the other hand, this proves that the code quality needs to improve. The basic parameters are the same as the old version, but there are a few additional ones, something like is pin and states and font. These three parameters was not exist in the old version. After successful going online, it creates a thread for logging keyboard input, just like the old version. However, the developer has rewritten this function, so there's no similarity to the old version. And the key log file name has been totally changed to the time and AT-API.sys. Next, it obtains the current host external IP and user information, UID, and then requires a command line from C2, as shown above. The C2 will then return a command. When it receives the pin request, the corresponding functions are as above. These upload files can also upload the screenshot, download, execute, and execute command line, just similar to the other backdoor. We also discovered that the attacker have used a new legitimate certificate. Using the email address in the certificate, we found a website, a screenshot on the upper right, but we can't tell for sure whether the website is fake. According to our analysis, the attacker may have faked the copied the legitimate website, see the screenshot on the upper left, and use this fake website applied for certificate through legitimate channels. or they just maybe stolen the certificate from a legitimate company. So according to the signature of certificate, we can find many samples that covering almost all the tools were used recently by Dropping Elephant. The certificate has now been revoked by its issuer Statistical, and the faked website also offline. Okay, last section. Let's talk about the infrastructure. So Dropping Elephants continue to use various hosting providers like Dino, Bell Cloud, and Clear that host. And as you can see in this table, Dino and Bell Cloud have been preferred your recent tag. And the domain name are usually registered with Namecheap. In addition to use the Dino's cloud server, Dropping Elephants also use the dynamic domain service provided by Dino. Interestingly, all DDNS domains are reserved and point to Bell Cloud servers, not Dino's. Okay, well, this is just a summary report showing the new stuff we have seen. So if you are interested in any part of it, please contact me, or we can discover maybe some more interesting things together. So thank you for listening.